Um, Good to see you guys. I hope you're having a good time so far. My name is Michael. I'm here with Chebbe de Winter. And we're going to try to entertain you guys on a couple of things. First of all, just quickly about Arista. Arista makes Ethernet switches like any other network vendor. For those who don't know Arista, I'm going to talk just a couple of minutes, and then I'm going to hand it over to Chebbe, who's going to talk about the OpenStack implementation they actually did recently. Basically, I want to use this graph to explain the history a little bit about software. I'm not a historian, but just that in the 70s it all started with a monolithic code base system, and then in the 90s people started to realize, hey, the monolithic code base where you have thousands of lines in one code block doesn't scale, doesn't perform, so let's make it modular. So basically what they did, every feature, every spanning tree or SNMP now has its own daemon, so to speak. So we came basically later, and we've learned from the past. And basically, if you look nowadays, what a switch is, it's just a Linux box. It's a box with a lot of 10 gig ports, and it runs Linux underneath it. So all these operating systems has a Linux kernel. The difference is that someone are using FreeBSD, we're using Fedora. So our operating system is called EOS, Extensible Operating System, is based on Fedora. And the difference with with the previous operating system is that we haven't modified our kernel. So it's a FreeBSD, a Fedora kernel, which hasn't been modified, because as soon as you start modifying your kernel, you kind of disconnect from the open community. And that's one of the things we learned, and we said we're going to keep the kernel. So basically you can run any RPM which is compiled on Fedora, you can run it on the box, on the Linux switch. It's all about software, but in the past it was all about custom ASIC. You're going to make your own ASIC and then provide it to the ASIC manufacturers, and then these guys would go and spin your ASIC for you. Nowadays the merchant silicoms has become, because of the volume, basically are more interesting than creating your own custom ASIC. So we don't make our own ASICs. We're using merchant silicons. If you look at our software architecture is decoupled from the hardware. So we can pick any other, any vendor, merchant silicon vendor, to build our switches. Now we're here to talk about OpenStack. If you look at Arista was founded in 2004. In 2008 we shipped our first product. And basically, we only started with OpenStack since the Havana release. And basically, it was exactly the transition between the previous and the ML2 plugin was introduced in the Havana release. So we have a great focus on Neutron, obviously, right? We're a network company. So basically, Neutron is ML2 plugin is the focus we have. One of our developers is part of the co-chairman at the ML2 meetings. I think the biggest opportunity for most vendors, network vendors, lies in the fact that, as an OpenStack developer, you expect the network to be there, and it runs, right? It should carry packets from A to B. But as an OpenStack, developer, engineer, you're kind of blind. You have no idea what's going on. So the biggest challenge for most vendors, and that's where the opportunity lies, and that's where we focus on, is to create visibility on the hardware, what's going on, right? So you know exactly what's going on underneath. So basically what it does, it enables you to give you visibility underneath the hardware. If you need to troubleshoot, 80% of the errors nowadays are still human errors. So basically what we enable is like a single pane of glass, and find out if something doesn't work, why it doesn't work, and you have all this visibility. We've got a presentation running downstairs, and basically what a presentation is that we're showing the ML2 plugin, which creates the SVIs, the VLANs, And then we're doing something with VXLAN. I don't know if you guys are familiar with VXLAN. VXLAN is just an overlay protocol where you can basically tunnel layer 2 over a layer 3 fabric. So basically what we've got a demo with 2 VTAPs. A VTAP is a virtual tunnel endpoint. And then there's running, an IP fabric based on BGP. And then that's how we demonstrate how we can basically provision a VM here. The VLANs are going to be created. Routing, if you want to interroute between VMs, the RVIs, the routed interface, are going to be created on the switch. And you're going to be able, this VM is in the same VLAN as this VM, and you're going to be able to talk to them. So that's basically what we're demonstrating downstairs. If you guys are interested, feel free to come and see us. That's it for now. I'm going to hand it over to this gentleman to do the talk on this implementation.
Thanks, Michael. So, a week ago I asked, should I do the presentation in Dutch or English? And the answer was Dutch. So, sorry for my cold-stone English then. So on the slides you will find some English and some Dutch items. Okay, who is CISO? So I'm Tjebbe de Winter. I'm technical and responsible for all we do at CISO. We're I think 7 years older than Arista. We've been around since 1997. We're a hosting provider doing tailor-made solutions for businesses. We're 35 people, and basically we make not money out of infrastructure, but we make money of managed services. So we take care, we think about how to scale and operate your business and have great uptime. So, and very important, we do a lot with cloud technology, but not that cloud things that you need for automating your office. We don't do virtual desktops and that kind of stuff. We only do things that result in a website or an API. So basically, we provision like HTTP or HTTPS applications. So this is our. Okay, so I'm going to talk about OpenStack, and an important question to ask is, so why OpenStack? There are a lot of other commercial or non-commercial options. First of all, OpenStack it's got a lot of momentum. That's why we're here right now. It's an open framework. There's a lot of adoption in the market. There are really a lot of competitors that all are working together in OpenStack, and among those companies are also companies that have their own commercial solutions, like VMware. So that's interesting to notice. It's a very serious, full-featured solution. I'm proud of my company, but we're only with 35 people. I think we're smart people. But we're not smart enough, and we will never be big enough to create something great like OpenStack. So if you want to compete with Amazon or Rackspace, you need to step on a train that will help you be competitive, and that's one of the great things about OpenStack. It can definitely compete with commercial vendors, but also you will profit from all the energy that's in the OpenStack project. So this is just some figure. You will see a lot of those figures, but this is the amount of commits, and these are all the different companies working at OpenStack, and there are more than this, but you can see it's really multi-vendor. It's Red Hat, it's Mirantis, it's VMware, it's HP, it's IBM. It's a lot of different companies trying to make it a success, and it's a success already. Yeah, cool. That works. Okay. Did I miss something? So, and there's another reason for us to do OpenStack. OpenStack means creating a cloud solution that's capable of running cattle. I don't know, you've probably heard it today, but old-fashioned servers are like pets. You know their name, and 80% of our work right now is we have all pets, we know their name, we even know their IP addresses out of our head. And we log in on those servers every month and update them and tweak the configuration, and we take care of our pets. And that's what we're very good at. But that's the old world. That's making old-fashioned monolithic applications, running on VMware and trying to do everything you can to get it some way or another redundant and available and scalable. And that's difficult. That's a lot of technology. And OpenStack is something different. It's not very suitable for running those old-fashioned VMware applications, but it's very suitable to run the new style applications that you automatically provision with some provisioning tool that can scale vertically. But that means a different way of thinking, not only for developers, but also for systems administrators, because now they don't need to know how to click in Microsoft Windows or how to do some tricks with VI, but they need to know how to operate Ansible or Chef or Puppet. And that's my Puppet Chef, because at our company we have a bunch of guys that really like Puppet, and of course we have another bunch of guys that really like Chef. So I've introduced the Puppet Chef, and basically it means it doesn't matter what kind of configuration management software you use, as long as you start using one of them. And I don't care which one. Using nothing is not an option. So for me, it's a way to inspire everyone at our company to learn how to deal with these kinds of things. Because if we don't, then probably we will not exist anymore in like 5 years. So, but still there are some challenges. If you use OpenStack for infrastructure as a service, that's typically a self-managed service. And for us, as a managed hosting provider, that's something new. That means that our customers can do all kinds of things themselves. And we don't like that idea. We want to be in control. Because not every customer is an IT expert, so they will probably do stupid things also. And that's no issue, but we don't want one customer to interfere with another. So basically it means that the infrastructure will have different use, different requirements, and it probably needs to be more stable and robust than a typical managed infrastructure. So it needs to be better than a VMware HA-like environment. So, but that's no problem, but you have to realize that you are building a very robust infrastructure. So, and what you need is, you need to be in control, and you need to think about security. And OpenStack is great, but it's a not so secure product. They fix like 3,000 bugs every 6 months. They introduce 300 to 400 new features every 6 months. So that's great, but that for sure will introduce all different kinds of security issues. So that means, and one of the things you have to do is you don't want to fix everything yourself, because you cannot fix 3,000 bugs in 6 months unless you have 1,000 people. So you need to keep up with the OpenStack train, and you have to think about it. So if you do it yourself, then you have to create a development cycle where you can cope with the OpenStack releases. And if you go for Mirantis or Red Hat or SUSE, you have to ask them questions. Okay, but if there is a specific, very important security issue, how do you deal with it? How long do I need to wait before I can install it on my cluster? Can I update my OpenStack to a new version every 6 months without downtime? That's a very important question. We have OpenStack, it's running now for 9 months within our organization, and it's still not in public beta. I hope to have it like in 2 months. And that's because we want to have everything set to go to every 6 months, replace our current version with the newest version, and go with the OpenStack train. Because as soon as you fall off, you're dead, basically. So this is something so October, so next month, there will be a new release. And around the new release, there will also be design summits. And in a design summit, they think of, okay, this is great, we need to, and so they will think now about 200 new features, and within 6 months, all those features will be implemented. So that's very fast. That's what's nice. That's why it does bring some innovation. But you also need to be able to keep up. So one of the things we did, and if you use the OpenStack packages just from the OpenStack Foundation itself, so not a commercial supported version, then you have to think about the branches you need to support and what you need to do if you want to fix a bug. And it's not an issue to fix a bug, but it is an issue to remove your own patch and replace it by the official patch that probably will be released 1 or 2 or 3 weeks after you fixed it yourself. And that also means that it's nice to have a stack running on your brand new hardware, but it's also very important to have a good testing and acceptance environment where you can easily roll out new OpenStack platforms, test your new server, test your patches, and after you've accepted them, put them into production. And that's, we use Arista switches to integrate our OpenStack with our network. And so in our testing environment, we also use the virtual EOS appliances to do the testing also on the Arista part. So something else about control and security is as soon as you start working with software-defined networking, and basically Neutron is a software-defined networking minimalist controller, their network operators don't like that idea because they don't know what's going on in the network anymore. If the slide that Michael showed us with a VXLAN connection between A and B, from a network operator point of view, it's traffic flowing, but he doesn't know where it comes from. He doesn't know where it's going to, which VLAN is inside the VXLAN tunnel, and if you want to debug, or even if you want to know what's going on, that can be quite difficult. So it's basically a black box, but we need to be able to push the red button and see what's going on inside. So, and that's something you need to think about. And for instance, if you use a good ML2 driver from Arista or another vendor, it should have the possibility to link your physical network with your OpenStack infrastructure, so you can ask your switch which customers, which VLANs, which instances are active on this port. So you can give your network operating guys the tools they need to debug if there is a problem. And you also needed to get it accepted because they don't want to lose the control they're used to. You don't want them to manually do all the switch configuration because that's not scalable. It needs to be automatic. So this is a solution. And the last thing is automatically provision. Our OpenStack, we can tear it apart, the hardware stack, so just swap all disks, format everything, push a button and wait. And after 1 hour, we've installed our OpenStack stack, we've installed our Ceph storage cluster, we've installed everything we use. And that's the only way it's going to work, because that's how you can also easily roll out new testing environments. And that's also that you know for sure that the 4,000 different configuration settings that Alan mentioned, that you have them right on every node. And if it's not right, you change your Puppet configuration or Ansible or whatnot, and retry until you fixed it. And that will really help with the stability of your platform. And also, from an orchestration point of view, you need to provision your OpenStack instances, but it also means you have to have a link between your physical network and your OpenStack. And it shouldn't need any manual configuration. So it's nice to run, for instance, a Puppet agent on an Arista switch to make it part of this fully automated setup. So, and if you do all that, you will get You will get stability on your configuration. But there are also, of course, some other things you need to take care of. You just need lots of storage, lots of compute, fast network, and the most important thing, you need to be able to grow fast. And you can only grow fast if you can send anyone to the data center that just throws in hardware and you only have to push a button. Okay, provision this hardware and let's go. And of course, that's the way how Amazon works and how Rackspace works. What nice is about OpenStack, it enables companies like CISO to have their operations on the same level. That's interesting. This is basically telling the same. Okay, so why do we use Arista for networking? This is because the future is clouded, meaning OpenStack is changing rapidly. Every 6 months there's a new release. In every new release there will be 400 new options, but they also now and then will change things. And now we have Neutron, and if they think the Neutron solution is not good enough, they will replace it within 6 months with something completely different. And you need to be able to cope with that. So we think that a switch platform based on Linux, where you have where it's supported to do your own magic on those machines, will give you the flexibility you need to adapt as OpenStack moves. And then and OpenStack is really a magic word. If you have a support ticket with like a company like Arista, and you're knowledgeable and you mention OpenStack, then you will get to talk to the right people in no time. And of course, the virtual Aristas are very handy for testing purposes. It's robust hardware, and you can make simple setups. And I like always the keep it simple, stupid. So what we did with OpenStack, we said, okay, we want to build everything based on open source. Of course, you can buy a lot of closed source solutions for your object storage or whatnot. So, but we try to build everything based on open source. We do it ourselves, so we don't use Mirantis or SUSE or Red Hat. We're creating our own. This is our stack. It's just Dell machines. The R720s are machines with 24 disks. The 620s are machines where you can put a lot of memory and fast CPUs in. Everything has a minimum of 20 gigabits to 2 different Arista switches. So one can break down, you can update without having a loss of connectivity. And we did some work on making the Neutron high available. Because if your Neutron goes down, if your control node goes down, all your networking will stop. And that's it then. Okay, so I have 5 minutes left. Questions?
I appreciate that you have to follow this 6-month cycle, right?
Yeah.
And if somebody at OpenStack thought about it, it probably worked too. But you say you have to have the automatic Puppet or chef provisioning and whatnot, which is a fair point.
Yeah.
Because you can deploy quickly. But if you update your stack, your Puppet configuration is useless. So do you have to, what is your strategy? Do you reinstall a new version and try to have the configuration management follow the new version? Or do you test deploying the new version with Puppet and then run it over your old stack?
That's a very good question. So first of all, we try to piggyback on the work that OpenStack does as much as possible. That's what this is about. Only do yourself what's really necessary. So what we use is we use the Puppet scripts that are available on the OpenStack website. So, and of course, if there's a new release, there is a lot of things not working, but we try to keep as close as the public available sources as possible. So, and when a new release comes out, we will test our new Puppet environment. We roll out test OpenStack instances in VMware. And so we use VMware as a virtual environment to emulate our hardware to automatically install our OpenStack stack. And as soon as that works okay, then yeah, it's right. We need to replace our current OpenStack setup because OpenStack doesn't really have an upgrade option. Not really.
That's what I'm following, because it's not only doing the OpenStack. You have to do your upgrade management too, because the moment you update, it's useless.
Yeah.
So you plug in the update scripts in the current Puppet setup.
Yeah.
And that would be your new evolution, or do you have to rebuild it from scratch when it's done? You understand? Because otherwise you're always bound to install OpenStack version 8.
Yeah.
And then run your Puppet configs to get to 10 every time.
I think it depends on if it's a major update or a minor update. So just updates within a release can be just done by testing them and then rolling them out to your production environment. And if it's a new release, then depending on how what is changed, we will basically reinstall our production setup.
The ARM720RX machine, Dell, it's a really nice hardware. I agree completely. But it's quite expensive regarding disk space, memory.
Yeah.
Do you buy all the services from Dell, or you
No.
suggest?
So it's true. The 720s are nice, but they're quite.
Het is tijd om te wisselen.
So yeah.
So guys, I suggested you go to ask Chairman the questions if you have any questions.
So but
We're downstairs.
volgens mij is ja, hij doet nog. But basically, we buy the disks that we use, especially the SSDs. We buy them directly. That's the trick.
Thanks a lot, Chairman.